Okay. So, hello everyone. I'm Sebastiano. I work at Novoda in London. I'm an Android GD. And today I'm going to show you a few tips and tricks that you can use to save time and avoid bugs without actually using anything weird, any third-party, anything. So, I would like to begin my talk with a step back in the past. Step back to when things were easier, back in the early days of Android, where they weren't really necessarily easier, because, well, back then, well, yeah, things were in a way easier because we still had to to bring some food home, and we did do our job anyways as Android developers. I don't know, many of you have been in Android development since the early days, but if you have, then you will remember that the tools we had back in the day, they look pretty much like this compared to what we have today. So some of them have evolved into things that we still use today. Some of them are still there as they are. Some of them has went away, luckily enough. And today we have something better. We have Android Studio, which is a really cool IDE, and it opens up a wealth of opportunities that we didn't have when we were still using Eclipse. And recently Android Studio has been promoted to 1.3 and final. Right now there's the 1.4 in the preview channel, which has even more cool things. But for today I'm just going to stay on the stable stuff because, yeah, not everybody likes to live in the danger zone. Anyway, first of all, I don't know if that ever happened to you, but I'm going to show a few quotes that I swear I've said or thought at least once during my work. So, how can this be a null pointer? Or I think, and I really wish that it was some kind of typing because I keep passing the wrong type of resource ID. Why is this text view not red? It should be red. It's black. What's wrong with world and what's happening? No, I never said this one. And then, yeah, the last one is, how is this crashing? It says I'm touching a view from a thread that is not the UI one, but I'm quite sure I am. What's going on? So, well, yeah, you have those moments where you're like, no, it's not that. What's wrong? Well, I have good news for you. I will show you how to fix all of those and more. Well, besides the Eclipse thing, there's no cure for that. But you will see that using annotations and XML attributes, we can at least ease the pain of dealing with those issues. So right now, I'm going to have a surprise question because no, I'm not going to lie, there's no interactive talk. I'm just going to blabber for 40 minutes. But there's one question, which is, how many of you have heard of Lint? I hope most of you. Yeah, good. So Lint is a static analysis tool that was originally born for C and was developed back in 1979, speaking of old times. Today there's a Lint for basically almost every language out there, and Android is no different, although Android is not technically a language, it's a platform, but we do get a Lint in the tool set. As I said, it does perform static code analysis, so it can give you warnings and point out mistakes like common pitfalls and things like that. And it can save you quite a few swearings. So that is why it should always be part of your CI builds, because you do have CI builds, right? I hope so. You should. And you should have other static analysis tools as well in your CI builds, because that will save you a lot of time and bugs. But why did I mention Lint? Well, I mentioned Lint because one of the things I'm going to show you today are the XML attributes in the tools namespace, which are surprisingly enough, they are all grouped into the big name of tool namespace attributes. So these attributes are built into the SDK and into Android Studio, and are used by Lint and by Android Studio to help inform the analysis about what's going on and what should actually be going on. They are built in a way that makes them safe to commit into VCS. So if you're using Git or Mercurial or, I hope not, Dropbox to version your code, then most of the attributes can be committed. It's usually safe. Some of them you probably don't want to because they don't really make much sense, but some of them do. And one example of things that sometimes do and sometimes don't, and also one of the coolest things that you can do with the tools namespace is design time overrides. What design time overrides is a fancy name for a really simple thing, which is you can take any attribute of the Android namespace, change the namespace from Android to tools, and whatever you specify there will only be applied to the preview in the IDE. It will never ship in the APK, which is cool because, for example, you might have some sample data that you show in text views or images that you don't want to actually bind at runtime. So using this, you can have something like a simple text view. You all know that if you do have that in a layout, this is the preview. You don't see anything at all. But you don't want to have Android text equals something because there's the risk of committing something under VCS that then will end up in the APK. And if you use swear words as test data, which you shouldn't, but you could, then they will end up in the APK. Same goes for sensible data, of course. Like if you have the bad idea of using real username and password for mock data, probably not the best idea. But if you use the tools text instead of Android text, then you're sure it will never ship in the APK. But what you can do is basically you just specify tools text, and you get a preview. So it's as if you have actually had bound the text to the text view. There was something I was meant to say here, but I don't remember. So just kind of go ahead. This goes for, again, all the attributes in the Android namespace, which means the vast majority of the attributes you will have in your layouts anyway. But this it's really cool and it's really powerful. But then again, most of the things you want, you can commit. So for example, a text or an image in a layout can be useful because the next person that opens up the layout can see something instead of having a white screen. Other things might not make as much sense, but it's always good, in my opinion, to have some idea of how things will look like in the IDE before running. Also because deploying takes time, as you know. But there's not only that in the tools namespace. There's actually a quite sizable set of attributes that come with it that I like to split up in two families. One is the Lint attributes, and the other one is the design attributes. We're going to look at the Lint attributes first. So the first Lint attributes, you probably have already seen it by now, is ignore. Ignore is basically the XML equivalent of the suppress warnings annotation that you use in Java. For example, here I have an application node in my manifest, and the IDE or Lint will point out that I'm not setting the allow backup attribute on it. So what I can do is, well, what I should do is specifying the attribute, but this is the first example I could think of. If you were to say, well, actually I'm okay not specifying it because reasons, then what you can do is just add in tools :ignore and then use the inspection name, and then Lint and Android Studio will not tell you anymore about that problem. By the way, these are inserted by the IDE automatically when you say ignore this, suppress this warning for this element. So you don't have to know the codes by heart, which is quite a good thing. Next up is targetApi. That's what it says on the tin. It's the same as the targetApi annotation in Java. So here, for example, I might have a style that is in the default values folder, and this will point out, well, you're using elevation, but elevation has only been introduced in API 21, and you're targeting your minimum SDK is KitKat, which will mean, well, it will not do anything because this is not Java, this is XML, so it's just going to get ignored, which in this case we might be fine with, so it might be a fad. And then we say, well, before Lollipop, we don't really care about showing a shadow on the floating action button. We're fine with it. So yeah, just ignore it, and I'm fine. Another attribute that has limited usage in my experience, but it's still there nonetheless, is locale. The only real case I could find that it would do anything useful is to help the spell checking in the IDE. So spell checking in the IDE by default only works for English. And if you do have values -en strings in there, then the spell checker will kick in and tell you if you have anything wrong. But if you have things in the default values folder, it will assume that they might not be English, so it just doesn't kick in. So you can add a local en in the file to make it work. Or you can actually use it the other way around. So say, I'm Italian, so I'm writing an application that is only going to be meaningful for Italian, so it doesn't have any other localization. So I'm just going to have all the strings in the main folder. And in that case, I can put locale IT, and then the IDE will know that this is Italian. At the moment, it just basically turns off spell checking, but in the future, it might actually turn on spell checking for Italian, which might be useful. This is just really quickly the lint attributes. So now, the other family, which is the bigger family, is the design attributes. The first one is context. Context is probably the oldest or one of the oldest attributes in the tools namespace. In the design side of things. It used to be called activity when it first appeared, but then they changed it to context because what this attribute does is it says to Android Studio, well, this layout is going to be used within this context. So that way, instead of having what is the default theme, for example, in the preview, the IDE knows that, well, this is actually going to be used in this activity that has this theme, so the preview can actually show you how it's going to look really. It's been probably, I guess, renamed from activity to context because this can be used on any layout, and the layout is not necessarily tied to an activity. It might be tied to a fragment, for example, or to a custom view that then, if you only use in one activity, then you know that you can use context in there and you're going to get the right theme. Another really cool attribute I find is showIn. So I guess you know that you can use merge and include in your layouts to reuse bits and pieces of UI. The problem with merges is that the layout preview by default is really pointless because merges are treated as frame layouts, and most of the time you actually inflate them inside of linear layouts or relative layouts, so you lose all the context of what's around the include you're working on. And there is an easy way to say, okay, I'm going to use this layout, for example, in there, so you can get in the preview something like this. It shows it in the context of the activity where it will be used. This only works for one activity at a time, unfortunately, but it's relatively easy to just swap around the layout name in the XML if you want to try it in different places. And it's still usually better than what you get anyway. Another caveat with this one is that you have to have an include tag that references that layout in the layout you specify in the attribute, because otherwise Android Studio doesn't know where the layout should be inflated in. Next up is menu. So menu, surprisingly enough, shows you a preview of the menu. So in this case, I have a really simple menu that is called map. It's actually a resource named map.xml in the menu folder. There's a thing that has to be pointed out about menu is that differently from other attributes around you will find, this doesn't take the @type / name. This only takes the name because you can have more than one menu. So you could have like menu, comma, settings, comma, common, for example, and then you would inflate all of them. There's another thing to be said, which is this attribute does not work with app-compat themes. I guess it's because the way the toolbar is treated when you use app-compat themes that is attached later because you have to set the support action bar using the toolbar later, and it doesn't do it. I don't know if it's going to be fixed at some point or not, but this is it. There's a few that actually have the caveat. Another one is actionBarNavMode. Action bar is the key. So we have our activity, and we say, well, I'm actually going to have tabs in there. So I want to see how it would look having tabs underneath my action bar. Well, you can add the attribute actionBarNavMode and say tabs. You can specify standard, tabs, spinner, and none, I think, which is not really useful. But this is in theory, because in practice, this doesn't work with material design, themes, and with app-compat. If you look at it, those navigation modes have been deprecated, so you should not be using them with the toolbar anyway, which I guess, again, explains why they don't work. Next up, this is a really simple one, and this is another one that you've probably already seen, is layout. So if you have a fragment in your layout, by default it shows up as a gray block that says, I'm a fragment. But it doesn't show you the contents of the fragment. This is because fragment views are created at runtime. They're not specified in a straightforward way necessarily. So this doesn't work. But again, you can just use the tools layout attribute and it will show you the actual layout of the fragment. Android Studio will actually nag you saying, you have a fragment, you're not showing any layout, click here to assign one. So there's a quick fix for this one, which is quite useful. After this, still, there's a subfamily of attributes, which is the list family. So there's list header, list item, and list footer. As you know, list views can have headers and footers, plus items. This allows you to get something better than the default list preview that just uses the simple list item to layout from the framework. If you add those attributes, you can have something looking a bit better and more close to what you will actually have at runtime. You might notice two things. The first one is only the first line is using the layout we told them to, because reasons, I don't know. Honestly, I don't know. Also, if you notice that the other items are using yet another different layout, so that's probably a bug, but I don't know. It's still good enough, in my opinion. And the other thing is, if you have a footer, if you specify a footer, you will most likely never see it because it's at the bottom of the list and you can't scroll it in the preview, so it's just never going to show up. It's there, probably. Hopefully. I don't know. And there's one big thing. When I was preparing this slide, I was putting in the attributes in the code and seeing they don't show up. It doesn't work. It doesn't work. It doesn't work. Then I realized that it only works if you have an ID on the list. So if your list doesn't have an ID, those will not work. Beats me. But then it does work that way. If you want to have some more information about the XML attributes in the tool namespace, I have 2 blog posts on Medium that contain information. The QR code is for the first one. And before anyone asks, yes, I've reused the name for the slides because I'm lazy. Another thing that you can look at is on the Android Tools website. There's actually a pretty nice write-up that I based my research on, plus some experimenting. So if you want to look at that as well, that's a fairly long page with all the information you might need, hopefully. Okay, so that was for the XML stuff. Now let's move back to Java. And in Java, we can use another thing, a really cool thing, which is the support annotations. Support annotations have been introduced in the support library starting in version 19, if I could recall correctly. You have to add them to your class path as a separate dependency because it's a separate member of the support family, support library family. But luckily enough, support v4 and thus support v7 do depend on the annotations library. So you basically always get them for free in your class path anyway. So there's no really, I don't think anyone ever builds anything without either support v4 or support v7. So you get it in your class path. There's a bunch of annotations in there. I will start with the easiest and probably most useful one, which is the nullability annotations. What the nullability annotations allow you to do is to define a contract for your code, saying, well, this field will never be null, has not to be null, or can be null, and you should guard against this. And this can be applied, these annotations, nullable and non-null, can be applied to fields, to parameters, and to methods, meaning the return value of the method has been annotated. So as a small example in here, you can see there's a simple trim function, but then you know that what you get as a parameter passed in might be null. In this case, you know it because you know how it's used, but the IDE doesn't have that information. So if you want to say, okay, my method can actually handle that kind of input, you might want to add nullable annotation. This will light up a possible null pointer exception in your code, because there you're trying to reference something that might be null and calling a method in it. So the IDE will help you a lot avoiding null pointers if you do use these annotations. And so it will tell you, well, this might produce a null pointer exception because you told me that thing might explicitly be null and you're accepting nulls. This is different from not annotating at all because that doesn't imply anything. This is explicitly saying I can take a null and I can deal with it. I don't have sunglasses to put on, but another thing you can do is, let's assume you're actually writing a safe trim method. So a safe trim could look something like this. Well, you can say, wait a minute, I actually never want to deal with null in this function because reasons. So what you would do is you would annotate your parameter with the non-null annotation. This will in turn make Android Studio and Lint tell you that condition is always false because you never get a null in. So you can actually simplify your code, take out that one, and go back to the code we had at the beginning. So you can, these are really stupid examples, but you can imagine how helpful it can be in a big chunk of business logic, being able to know exactly when you need to check for nullness. You can avoid redundant checks, and then you can also be sure that you always have checks when you need them. And if you have a library, or if you're exposing some public API, this is especially useful for clients. So whoever uses your library knows what they can and can't pass or expect from your code. Moving on to the next type of annotation is the resource ID annotations. There's actually a bunch of them. Basically, any REST type has got its own annotation. Why? As I said before, if you remember, one of the quotes was, I have no idea, this is just a simple int. I have no idea what I'm actually supposed to be passing in. And there's actually the worst case is when you're trying to deal with colors, because colors are integers themselves. So what you would do is, like in this case, you have a method that is supposed to take a resource ID, and you might be passing in the resource ID if you're doing it right, but you might be also passing in the resolved color, which in turn will crash the application because getColor will not find a resource that matches the the color you're passing in. So you can, you will have something like, the IDE will say, well, this is a set color, set text color. So usually what these methods do is they take a color resource, not a resolved color. So what you can do, they take a resolved color, not a resource ID. So what you can do is you can add an annotation in there, which is the color res, that tells the user, well, in here, I need to get r.color.something, not the resolved color, because I'm dealing with it myself. And this goes for color, but there's, again, you can have layout, integers, basically anything. There's really a lot of them. There's even one that you can see in the first column, which is any res. Basically, any resource ID is good in there. I don't see that many uses for it, but it's there. On the other hand, speaking of colors, you might have the opposite problem. So you might have something that is expecting a resolved color, so proper color integer, not a resource ID. So this thing will fail. Will be the classic, oh, the text should be red, it's black. Why? Or it's random puke color. What you can do is, again, use the annotation to make your contract explicit. I'm expecting an actual color in here, not a resource ID. And this will, in turn, make Android Studio light that up and say, well, that should be a color, not a resource ID. So you will have this safety net, which is, again, really helpful, especially for if you're writing a library. You should really use those. Next up, ranges. So there is, again, no type safety or no safety net or contract when you're just dealing with normal colors values. You can use the float range and int range annotations for that. What they do is you assume you have a method that assumes that the value that is passed in is between 0 and 10. What you would usually do is check the value in the method and then throw an exception or something. What you can do instead is you can specify the range you're expecting. That way you don't have to write the check yourself. You keep the code clear. And at the same time, you get the IDE warning you. And one thing, this goes for floats and integers. The integers one works for longs as well. So any kind of numeric value is covered. This is also true for arrays. Arrays usually don't have any contract of how many elements they're supposed to contain. So you have, for example, set coordinates method. Intuitively, you say, well, it takes 2 coordinates, but it might be taking 3, or it might be taking 1 because you're using some weird coordinate space. What this does is you can add the size annotation in there, and that will light up the fact that you're passing in 1 value instead of 2. You can also have a minimum amount of values in there. You can also have a multiple amount. So you can say, I am taking pairs of coordinates, so I need something that is a multiple of 2. So it will only work if I get 2, 4, 6, or so on, which is kind of nice. Next up, TypeDef. So TypeDef annotations are useful in the case you are using integers or strings instead of enums. Now, there's a big debate going on right now on whether you should actually do it or not. I would say, as with all rules, there's moments where they make sense and moments where they don't. If you're in one of the moments where you're actually really trying to save the last byte you can in the memory and trying to save as much memory overhead as you can, then you can use integers, for example. But the problem is, you see here, style, I'm expecting to get one of those 2. But I can actually assign anything to it, and no one is going to stop me, because this is not an enum, this is normal int. So what I can do is I can define an annotation that I can call style in this case, and I can say these are the values that this annotation can take. And this way, when I go back to my code and I actually annotate my variable or field with the annotation that I just defined, well, the IDE will complain that I'm just passing something that it's not expecting. So this is quite useful. And all these annotations are used in the framework code and in the support library code to help you dealing with this kind of thing. Next up is the threading. So you can say, you remember the touching a view from a non-UI thread kind of situation. Well, in this case, assume this is called from some background thread. This looks fine if you look at it and you're not paying attention where this is called from. But it will crash your application. So what you can do is you can say this method is supposed to be run on a worker thread. And then what happens is the IDE tells you, well, you're trying to do something you should never do on the worker thread, which is touching the UI. Again, framework methods are annotated. So if you are using an intent service or, well, it doesn't really have anything to do with UI. But if you're using async tasks, this will save you quite a lot of headaches if you're trying to do something in the doing background method. And there's actually 4 annotations in the family: main thread, UI thread, binder thread, and worker thread. You might think main thread and UI thread are the same thing. Yes and no. There's only one main thread in a process, which also is a UI thread. But in an application, you can have multiple UI threads. So you need both of them. But most of the time, you will just use the main thread annotation anyway. Next up is the architecture annotations. There's 3 of them. They do what they say on the tin pretty much. One is call super, meaning this method, if it's overridden, needs to call back to the super. Another one is check result, meaning I'm giving you back something that you should use. So if the IDE detects that you're not using the return value of this method, it's probably because you forgot to. So you can warn you of that. And you can also specify what you're supposed to be doing with it. So for example, if you have in Marshmallow, you are checking for a permission, then the method is annotated with check result. And will tell you, well, this method returns you something that then you should use to enforce, to request the annotation, the permission if you're not having it. And then there's visible for testing. It doesn't really do much. It's like a marker that says this field or symbol has a broader visibility than it should because I'm using it somewhere to test. So I need access to it. This is useful, I think, especially for code reviews, because otherwise people will bitch at you. So permissions annotations, these have been introduced and supported in 1.3, so Android Studio and Gradle plugin. Assume I have a library that does Bluetooth scan, and for some reason the library is not declaring in the manifest, because it might be like a jar or something like that. It's not declaring in the manifest that I'm using this permission. So what I can do is I can say, well, if you call this method, your application must have this permission, or any of these permissions. You can specify a list, or all of these permissions. This way, when you call it and you don't have the permission in your app's manifest, the IDE will tell you, well, you need to add this, and then also offer you a quick fix to add it, which is quite cool. For content providers, you actually even have the possibility to specify different permissions for reading and writing to it. So you can have a pretty solid contract that people can rely on. Last thing in the support annotations is the Proguard annotation. So this is used to auto-generate the Proguard rules file. Or rather, would be if it worked. It doesn't right now. The patch is under review or has been reviewed, but it's not merged in 1.3 yet that I know of. Probably is going to be working, hopefully, in 1.4, so it's something that is still worth knowing. So you don't have to go and manually keep the package names and method names or class names in the Proguard configuration file up to date. This is going to be generated for you, and I think this is quite cool. So wrapping up support annotations, there is a nice write-up that has been put up recently on the Android developers website, which gives you it says most of the things I've said. It's fairly new, so it doesn't cover everything. But if you do want to have more information, there's also the Good Old Tools website, which has another write-up. And they are pretty much the same in some things, but they don't completely overlap each other. So you might want to check that out as well. So yeah, that was it for support annotations. Now, I would usually go for a Q&A, but still have 5 minutes-ish, and I'd rather show you one last cool trick, because I love you people. So there's a bonus round, which is view debugging. There's one more annotation, which is not in the support library. It's actually in the SDK, and it's been there forever, but nobody knows about it. So there's this class, which is called view debug. View debug exposes a bunch of functionality that you can use to help debugging your views at runtime. So I guess you all know about the existence of hierarchy viewer, which is now inside of the Android device monitor tool. Well, if you have a custom view and you have your fancy property that might be like having a color or something, well, by default in hierarchy viewer, it doesn't show up anywhere. So this is just a part of the attributes, but of the things you would see in view debug, in a hierarchy viewer, but it is nowhere to be found. What you can do is you can add the exported property annotation to your getter. So if you have a getter that doesn't take any parameter, you can annotate that way, and it will show up. You can also set a category. So by default, it shows up in the miscellaneous category, but you can have your own category. So you can have like custom attributes or my text fancy things or whatever you want. And it's really cool. You can also do way more things. So for example, if you have an integer that is a set of flags or a flag, you can map the value to literal values so you can see the strings. That is, for example, how hierarchy viewer knows that visibility 0 means gone and show you gone instead of 0, which is way more useful. And then you can, so here you can see I have a color that is shown as an integer. It's not of much use, but then you can specify, well, show it as a hex string, so you get something you can read. Just go and look at the Java doc. Most of the stuff that was in the view debug class has been deprecated in Jelly Bean, so API 16. But the exported property and a handful of other things are still there and are still as useful as they were. So I think I have a couple of minutes, so if we actually want to have some questions, we can. So this time is really Q&A. But you can also tweet me any questions you might have, and I'll reply, probably. Unless really weird questions. Anyway, I just want to thank you all very much for coming at this talk. I'm Sebastiano. These are my contacts. So yeah, if you have any